Welcome back everyone. In the last session we saw question number 2 of exercise 1.5, in which we simplified all these four bits by using different identities. Now proceed with the next question, that is the third question and the fifth question in this session. Question number 4 is a part of deleted portion, so we are going to skip question number 4. Okay, question number 4, this is deleted from your syllabus. So question number 3 and question number 5. Question number 5 is the most important concept of this chapter, I can say. So note that this is the most important concept and you need lot of practice on this concept, and you have to do many extra questions also. So let's begin with question number 3. In question number 3 he is asking to clarify that pi is an irrational number. I said you that pi is the only fraction, that is 22/7, which is irrational. Now, how do you get this pi value? How do you get this constant value? The pi is nothing but the circumference of a circle. You divide the circumference of a circle, any circle. Take any circle of any radius, any diameter, okay, and divide that. Okay, let's take a circle first. Let's take a circle. This is a circle, okay. If you find circumference of this circle, that is 2 pi r, or the length of this boundary, when you divide the circumference by diameter. What is diameter of circle? The chord which passes through the center, okay. Diameter is the chord which passes through the center. So this is the diameter. So when you divide the circumference with diameter, you always get 22/7, okay, and that is pi. That is the meaning of pi. So you always get 22/7. It's amazing, isn't it? Whatever may be the size of the circle, that doesn't matter. Whenever you divide the circumference with the diameter, you always get 22/7. So here you can see now pi is defined as a ratio of the circumference of a circle to its diameter, that is pi is equals to c by d. So this seems to contradict the fact that pi is irrational. When pi is 22/7, it should be rational, isn't it? Because every number which can be written in the form of p by q is rational. But why it is irrational? How will you resolve this contradiction? When c and d are both rational, this should be rational, but c and d when we calculate is not exactly a rational number, and either c or d both can be irrational numbers. When you calculate this, it will not be exactly rational numbers. So any one of those two, either c or either d, can be irrational. So rational by irrational is irrational. So we can finally say that pi is irrational. So in short, you remember that pi value is always an irrational number. Which number it is? Irrational number. Okay, it's an exceptional case. Next, before we go for question number 5, that is rationalize the denominator of the following. Let's see few basic concepts. So in the last session we have seen few bits in which we applied a plus b, a minus b formula, like example root 3 plus 1, root 3 plus 1. This is an irrational number because we have root 3 in this, isn't it? Now if I multiply this with root 3 minus 1, I get root 3 square minus 1 square. Okay, we have done this in second bit. Okay, in the second question we have done this all. So if I multiply this root 3 plus 1 with root 3 minus 1, I get root 3 square minus 1 square. I can cancel this square and root, so this becomes 3 and this 1 square is 1, and finally which number do I get? I get 2. That is a rational number, isn't it? 2 is a rational number. So I can say that root 3 plus 1 is rationalized. Root 3 plus 1 was irrational number. Yeah. So I multiplied it with root 3 minus 1. I got 2. So root 3 plus 1 is rationalized. This is the meaning of rationalization. Rationalization means converting irrational number into a rational number by multiplying it with its rationalizing factor. So here this root 3 minus 1 is called rationalizing factor of root 3 plus 1. What do we call it? This root 3 minus 1 is called rationalizing factor, RF. Rationalizing factor of root 3 plus 1. Let's see another example very quickly, or let's have a look at the question number 2, second bit, or the fourth bit. Any bit you can take, okay, or you can take your own example also. Root 5 minus root 2. So what should I multiply this with this to get irrational numbers? This is an irrational number, okay. Root 5 and root 2 both are irrational, so I have to convert it to rational number. So I'll multiply it with its rationalizing factor, that is root 5 plus root 2. So rationalizing factor means whenever you are finding rationalizing factor, this is rationalizing factor of this one, okay. So only the sign will change. Root 3 plus 1 because rationalizing factor is root 3 minus 1. Root 5 minus root 2, rationalizing factor is root 5 plus root 2. So only the sign will change and the numbers remains the same. So we will multiply this with root 5 plus root 2 and let's see what happens. So root 5, a plus b, a minus b I can apply here. So this becomes root 5 square and this becomes root 2 square. No, a square minus b square, square and root gets cancelled, 5, and here also square and root gets cancelled, minus 2. 5 minus 2 is 3. So finally root 5 minus root 2 is converted to a rational number. This is called rationalization. So what is rationalization? Converting an irrational number into a rational number by multiplying it with its rationalizing factor. So let's quickly see rationalizing factors of few terms. Let me draw a line here and let's write few rationalizing factors. So here this is the rationalizing factor RF and this is a term here, okay. So if you have root a minus root b, its rationalizing factor is root a plus root b. Okay, what happens? Only the sign will change. If you have root 3 minus 1, its rationalizing factor is root 3 plus 1. Then what is the rationalizing factor of root 3 plus 1? Root 3 minus 1, isn't it? So they are rationalizing factor of each other. Rationalizing factor of root 3 minus 1 is this, and rationalizing factor of root 3 plus 1 is this, I can say. Okay, vice versa. Then you can take any example, say root 5 plus 2, rationalizing factor will be root 5 minus 2. Very simple. If you have root 7, here what will you do now? Here two terms were there, you are changing the sign. If it is only root 7, then multiply root 7 only. Rationalizing factor of root 7 is root 7 only, because root 7 into root 7, when you multiply this both, you will get root 49, and root 49 is nothing but 7. So how to convert this irrational number into rational? Multiply it with same term again. Okay, when it is single term, you should not change any sign. When there are two terms, minus become plus, plus become minus. So this is the basic concept of rationalizing factor. The other name of rationalizing factor is conjugate. What is the other name of this? Conjugate. Okay, so now he is asking, rationalize the denominators of the following. So we will see